Okay. So, looks good. Hello, everybody. My name is Erik Brandsberg, Chief Architect of Heimdall Data. Today, we're going to be talking about how to improve database scale and improve costs without application code changes. Although we're going to go into potentially a few more features as well of how our software works and the techniques that we use in order to do this. So, who are we? Heimdall Data, we are a Microsoft technology partner. We're also a partner with, say, Amazon, as well as Google and Oracle Cloud providers. So our software is available in any of those environments, as well as on-prem, if that's where you are hosting your own applications. What is it that we do? We provide an intelligent database proxy that provides a whole portfolio of different functions that can be used in order to provide various benefits to customers. And we're going to be going into some of the most important features that we provide, but this is by no means a comprehensive presentation on what we can provide. Now, why do we do what we do? Often people have application problems as far as how the application interacts with the database. SQL performance is slow. And what we try to do is change how the applications interact with the database in order to improve performance or overall behavior. So the first thing we're going to go to kind of is a very brief overview of database proxies, what they are, and some of the competition that you may know about. Then we're going to go into the features that we provide, and I'll just go into kind of what the next steps would be if you wanted to try to evaluate us or use us within your own environment. So first off, database proxies. There's obviously Heimdall, which we'll go into in a lot more detail. There's Proxy SQL, which is only MySQL centric. There's PGPool 2, which is Postgres based, and PG Bouncer, which is also Postgres based. Not on this list, although it's Amazon Cloud specific. There's the RDS proxy, which supports MySQL, Postgres, and will soon support SQL Server as well. But the key to that is all it does is connection pooling. With Heimdall, we're not only doing connection pooling, which many proxies support, we do read-write split, we do query caching, we do integration with Active Directory. All these we'll go into in more detail in just a few moments. And let's see. Okay, let's talk about how a database proxy actually gets deployed. A proxy is simply a piece of software that sits between other pieces of software. So for database proxy, you have an application. You then have the proxy, which can be part of an auto-scaling cluster if you wish. And then you have your database. Now, as part of Heimdall, with the caching that we do, we also interact with other cache layers, such as Redis or Hazelcast is another cache provider that we interact with. And what those do is it allows to expand caching capability and allows for coherence of cache between multiple cache devices. This allows you to have a uniform view of what the cache is, even if you have many proxies operating at once. Okay, and let's get into query caching a little bit. With that, an application will generate a query. It hits the proxy. The first time it hits the proxy, it'll go through to the database. The result will come back. We will store the result of that query into the cache layer and return it to the application as well. Now, the hard part with caching, however, isn't storing the result. It's in validating the result. And that's where Heimdall provides a lot of intelligence. What we do is we parse not only the queries coming in for data, but we also parse the DML where data is changing. We know what tables are being changed. We know to invalidate the data against those tables that have been stored in cache. And as a result of that, we can guarantee that you're getting fresh data while improving the performance of queries that are repetitive over time. So this is the first feature that we can use to offload, say, a SQL Server environment, because the fastest query is the one that never even has to be processed on the database. Next, the next feature that we do is read-write split with strong consistency. Now, let's imagine you have an always-on availability cluster. You've got a primary writable node, and then you have a reader node or potentially multiple reader nodes. Most applications are not designed to use that reader node or even one reader node, much less more than one. So what Heimdall does is, again, since we're processing the queries, we're parsing them at the cache layer, we know what to read, what are reads, what are writes. We know what tables are being used as part of these queries, and we're able to use that same intelligence that we do at the cache layer to make a determination of, is it safe to use a reader? And one of the factors that we also have to add in here is the fact that there's a replication lag delay between the writer and the reader. So if you do a write and then an immediate read, if you read it from the read node, then what you're going to get is stale data. Heimdall automatically accounts for that and allows you to use that read node safely with strong consistency. Any questions? Okay. The great benefit of this is you don't have to change your application code. You can implement this functionality, just like with caching, with no changes. All you have to do is change the endpoint that your application is pointing to, do configuration within the Heimdall Management Console, and you can get these benefits. Now, next feature. And this is something that's a little bit more specialized, and it's generally something that you're going to encounter in the cloud, and that is proximity load balancing. Let's assume that you are using something like a global replication system for RDS SQL Server. You've got a reader in, say, California and another reader that's in New York. You've got proxies and application nodes for redundancy or disaster recovery in both locations that may be active at the same time. Well, with Heimdall, with the proximity load balancing, we can route the read queries for the application nodes that are in California to the reader node that's in California. For the application nodes that are in New York, we can route them to the read server that's in New York. The net result is that you get improved performance by deploying globally, but at the same time, you get the redundancy. If one fails, then it'll automatically cut over to using the readers in the other region. So this allows you to leverage the resources that you're deploying on a global basis for performance and redundancy, not just redundancy. Okay, another feature that we provide, and this is something that other proxies provide for other databases, although there aren't really good proxies for SQL Server aside from the RDS proxy, and that is connection pooling. So with that, if you have a bunch of different application servers or users coming into one proxy, we can reuse connections on that proxy to the database, reducing the amount of connection cycling that's happening on the back end. This reduces load on the database, improves efficiency, and then using additional functionality that we have called multiplexing, we can even share a backend connection for multiple active front-end connections at the same time. So most connection pooling, once a connection is open from the front, it will need a connection on the back. With our multiplexing, we take that a step further and we share it and look at the connections as if they were stateless connections on the back end. We can, in many cases, see a reduction of connections on the backend database by 100 to 1 or more. And that is not unrealistic. The next feature that we've implemented is what we're calling zero-touch user management. In many enterprise environments, they already have an Active Directory environment where they're managing all the users, they're managing the passwords, they're managing what groups a member or a employee is part of. They may be a member of HR, they may be a member of operations. Well, those groups can be used in conjunction with Heimdall, not only to provide administrative functionality, but to actually manage access to the database itself. So with this function, we will authenticate the user against Active Directory. If they're authenticated and the appropriate group filters say, yes, this is an appropriate set of roles, groups that relate to this database, we will create the user on the fly on the database as needed and map the roles based on those groups so they have access to the data. This makes for a great case for improving data governance in an enterprise environment, because now you have one source of truth for what users are part of what divisions in the organization. You have one password to manage, one place to do password resets. The IT help desk no longer needs to have root access into the database itself in order to correct these issues. It's all done via Active Directory. Any questions on this? Okay. So this is great if you have lots of users. This is most relevant for analytics environments, because in analytics you may have a lot of different people that are coming in doing ad hoc queries in order to answer questions. The bigger your data warehouse and the analytics environment, the more this can be useful. Okay, SQL performance analytics. A lot of different tools have ways that you can look at. Let me see here. A lot of tools have different ways that you can view what queries are coming in and being executed. However, a lot of those tools actually miss part of what's coming in. Now, this particular example is something that we're pulling from Postgres, but the same applies for tools with SQL Server as well. In this case, you see the first three queries are not actually queries for data, but they are control queries to deal with what the transaction state is. But if you look on the far left corner or column, when you add those up, that's almost 10% of the time spent waiting on the server is actually not doing queries. It's just figuring out the state of things, the connection. Well, Heimdall, being a proxy, sees all this, and even if the database doesn't report these as part of the query statistics, we can. Another interesting point is that a lot of tools do not actually report the size of the result set that's coming back. And that can be extremely important when dealing with performance, because it may not be how much time it takes to execute the query, but how much time it takes to deliver it, simply because it's a big result set. Heimdall allows you to see what those sizes are, and you can use that in order to very easily say, it's a 4 gigabyte result. Maybe we should tune that query. And a lot of our users, as soon as they plug us in and start getting analytics, they get a lot of surprises on the screen. Okay, especially that one column, because they didn't realize that those queries were turning quite so many results, or such a large result. Any questions so far? What? Oh, technically we could add in the row count. We have access to that information. We're just not exposing it at the moment. We found that a lot of tools seem to provide things like row count, but they don't tell you how big it is. So that's what we're kind of focusing on what's different, what's missing. Thank you. Okay, we are in the Azure Marketplace. When you install from the Marketplace, What happens is it's a central manager that you install. Through that manager, you can configure what we call a virtual database. That virtual database defines all the different parameters for what the servers are within the cluster. If you're in an appropriate cloud environment, we can detect when that cluster changes configuration. So if there's a failover, we can detect that automatically. And basically, we know that this reader is now a writer, so we start writing to the new writer. You don't have to change anything at the application level to make that work. We take care of all that for you. Okay? So kind of to summarize some of the functionality, database platform sits between the application and database, provides a bunch of different functions here. Now, since we have time, and any of you dealing with a SQL Server, dealing with analytics queries or hybrid environments where you're dealing with transactional and analytics in the same. Okay, so I see some people nodding. I'm going to talk about some features we don't have slides right here for in order to explain how we can benefit an environment like that as well. So we have a feature that I'm amusingly calling the penalty box. Okay? Any of you familiar with hockey terms? Yeah, something goes bad, they get put into the box and they have to wait. Eventually they'll come back out. Same idea here. We know when queries are long-running queries because we see what's going on, but also we know what queries generally are fast queries. So what we can do is use that information at runtime to say, you know what, if it's a fast query, just let it through to the database. It'll get dispatched very quickly. It's not going to cause a lot of overhead on the database. But something that takes a minute, 2 minutes, 10 minutes, an hour to run, yeah, that's a bad query. And you don't want many of those running at a time because they're generally going to be causing a lot of load and they may slow down all the other queries. So we put them in the penalty box and you can configure what that means. One thing you can do is say only allow 5 slow queries to execute at a time. Okay, you could also say, well, set the rate of how often they can execute. Or, even more interestingly, you can set up an alternate read server on your cluster, again, always on availability group, and if it's known to be slow or we don't know it's fast, send those reads to that alternate server so that its workload does not impact your other nodes. Net result is that you can have a hybrid environment where the fast transactional queries are not being impacted by your reporting or analytic queries. So that gives a nice balance so that you don't necessarily have to go to a split workload where you have, say, your BI environment just going off of nodes that are replicating for it. Everything can be done on one cluster, one endpoint, and the behaviors are taken care of automatically. Okay? Does this sound interesting for you guys? Okay, great question. Can you dictate behavior based on what user is coming in? Like the CEO is doing a report, you want him to get the answer as quickly as possible, but Joe Blow down in IT is running a report. Well, you know what? He can wait. Well, yes, you can do that. We can apply our rules based on things like user, application name, source IP, what table is being queried, what the query is based on regular expression, what port you're connecting on. You can set up multiple listener ports for Heimdall, and you could say port 1433 by default gets all the restrictions, but you tell your special users use 1434 and they bypass these rules. You can do that as well. So there's a lot of different controls and a lot of creativity that we give you in order to manage your environment and improve the behavior of the system as a whole. Any other questions? Okay. So thank you. We are available on at Heimdall.com. We also have a large number of blogs. If you search for, say, AWS Heimdall blog, you're going to find that we are actually published by AWS describing a lot of functionality that we do for a variety of databases. So if you're interested in any of these features, we have a blog on almost all of them going into details how the configuration is done. If you're interested in trying us out, we also have 30-day free trials for users, so you can see what type of benefit you can get without worrying about that. And, well, anything else? Okay, thank you.